Hi guys, in today's lesson, I'll be teaching us subshells and orbitals. So I want you guys to stay to the end of this lesson. If this is your first time coming across my video, I want you to subscribe to my YouTube channel at Divine Online Chemistry Tutorial. So let's get started in today's lesson. But if you have not watched my previous video on shells, energy level and electronic configuration, I want you guys to watch that my previous video so that when I'm explaining subshell and orbital, it will not be a big deal to us. So let's commence with today's lesson. Now in chemistry, subshell are also being represented with letters written in capital form, and they include S, P, D, and F. So these letters are usually being used to what? To represent subshell in chemistry. And then this S is what? S subshell. Then this or P subshell. Then we have D subshell. And then we have what? F. Then we have what? F subshell. So these are the various subshell that we have in chemistry. And please take note that these subshell have various shape. Now the S subshell is spherical in shape. It's spherical. Spherical in shape. Please take note of this. Now the S subshell is spherical in shape. Then the P subshell is dumbbell in shape. Dumbbell. The P subshell is dumbbell in shape. The D subshell is double dumbbell shape. Double dumbbell in shape. While the F subshell is what? Is complex in shape. So these are the various shape of these various subshell. The S subshell is what? Spherical in shape. The P subshell is dumbbell in shape. The D subshell is double dumbbell shape, while the F subshell is complex in shape. So you should please take note of what? Of the various shape of the subshell. And please you should also take note that each of these subshell have maximum number of electrons that they can carry. Just like the way shells in chemistry that is spinning around the nucleus of an atom have maximum number of electrons that it can carry. That's the same way subshell that is also spinning around the nucleus of an atom also have what? Maximum number of electrons that it can carry. Now this subshell, the maximum number of electrons that this subshell can carry can be proven by what? By a formula, and the formula is what? 2 into bracket 2L plus 1. So with this formula, we can calculate the maximum number of electrons that each of these subshell can carry. Where this L in the formula is what? Is what? Azimuthal quantum number. Please take note that L in the formula is what? Azimuthal quantum number. Azimuthal quantum number. So please take note that L in this formula is what? Azimuthal quantum number. Please also take note that this formula can be used to calculate the number of electrons that each of these subshell can carry, which the formula is 2 into bracket 2L plus 1, where L in the formula is what? Azimuthal quantum number. Please take note that this L, which happens to be the azimuthal quantum number, has value for each of what? Of these shells. Now the value for L, which happens to be the azimuthal quantum number for the S subshell, is what? Is 0. So L equal to 0 for the S subshell. Then L equal to 1 for the P subshell. L equal to 2 for the D subshell, while L equal to 3 for what? For the F subshell. Please we should take note of this. That L refers to what? Azimuthal quantum number. And this L, which happens to be the azimuthal quantum number, has value for each of these subshell. Then the L value for the S subshell happens to be what? 0. The L value for the P subshell happens to be what? 1. The L value for the D subshell happens to be what? 2. While the L value for the F subshell happens to be what? 3. Now having brought out all this, Now let's now calculate the maximum number of electrons that each of these subshell can carry. Please, if you find this class very interesting, I want you to subscribe to my YouTube channel at Divine Online Chemistry Tutorial. Don't forget to like my videos, to comment, and also share to your friends and loved ones. Let's continue with the class. So S subshell equal to, use the formula 2 into bracket 2L plus 1 close the bracket equal to 2 into bracket 2 times L. Now L for the S orbital is what? Is 0. Don't forget that plus 1, yes, P. And you close the bracket. So it becomes equal to, now 2 into bracket. Now 2 times 0 is what? Is 0 plus 1. So plus 1 equal to, now 0 plus 1. Okay, let me bring it out again. 2 into bracket. Now 0 plus 1 is what? Is 1. Please take note of that 0 plus 1 is what? Is 1. The 1 is still in bracket. Now 2 times these 2 outside times this 1 will give us 2 electrons. 2 electrons. So you can see that using this formula 2 into bracket 2L plus 1, we can calculate the maximum number of what? Electrons that each of these share. Okay, we calculate for the first shell, which are supposed to be what? The S subshell. And we have what? We got what? 2 electrons. So the maximum number of electrons that the S subshell can carry is what? Is 2 electrons. So please take note of this. Let's calculate for the P subshell. The P subshell. Use the formula 2 into bracket 2L plus 1 equal to 2 into bracket 2 times L for the P subshell is what? Is 1. Then plus 1. Close the bracket equal to, then we now have 2 into bracket. Now 2 times 1 is what? Is 2 plus 1. Close the bracket, then equal to 2 into bracket. 2 plus 1 is what? Is 3. Now equal to, now 2 outside times 3, because bracket means what? Times. So 2 outside times 3 will give us what? 6. 6 what? Electrons. 6 electrons. So the maximum number of electrons that the P subshell can carry is what? Is 6 electrons. So please take note of this. And let's calculate for the D subshell. D subshell equal to, using the formula 2 into bracket 2L plus 1 equal to 2 into bracket 2 times. Now L for the D orbital is what? Is 2. Is 2 plus 1. Close the bracket equal to, now 2 into open bracket. 2 times 2 is what? 4. Then plus 1 is still there. Take note of that. Close the bracket equal to, then we now have 2 into bracket. Now 4 plus 1 is what? Is 5. 5. Close the bracket equal to, now bracket means what? Times. So 2 outside times 5 inside the bracket is what? 10 electrons. 10 electrons. So the maximum number of electrons that the D subshell can carry is what? Is 10 electrons, as proposed by what? By the formula 2 into bracket 2L plus 1. Please take note of this. Now let's calculate for the last subshell, which happens to be what? The F subshell. So F subshell equal to, use the formula 2 into bracket 2L plus 1. Close the bracket equal to, now 2 times L for the F orbital is what? F subshell means what? Is 3 plus 1. Take note of this. So what? We'll close the bracket. Okay, I made a mistake. So it will be 2 into bracket 2 times. Now L for the what? For the F subshell is what? Is 3 plus 1. Now close the bracket equal to, now 2 open bracket. 3 times 2 is what? Is 6. 3 times 2, take note of 3 times 2 is what? 6 plus 1. Close the bracket equal to, now 2 into bracket. Now 6 plus 1 is what? 7. Close the bracket. So equal to, now 2 outside times 7 inside the bracket. Inside the bracket is what? Is 14. So 14 electrons. 14 electrons. So the maximum number of electrons that the F subshell can carry is what? 40 electrons, as proposed by what? By this formula. So with this formula, 2 into bracket 2F plus 1, we can calculate the maximum number of electrons that each of these subshell can what? Can carry. Now please don't forget that L in this formula is what? Azimuthal quantum number. So L in this formula is what? Azimuthal quantum number. And this L, which happens to be the azimuthal quantum number, has value for each of these subshell. And the L value for the S subshell is 0. The L value for the P subshell is 1. The L value for the D subshell is 2. While the L value for the F subshell is what? For the L subshell is what? Is 3. So guys, please take note of all these that I've just brought out right now. So from here, we'll be moving straight to what? To orbitals. Please take note that orbitals, they are derived from subshells. So orbitals, like I said earlier on, they are what? They are derived from where? From subshells. Now, what are orbitals? Orbitals are regions across the nucleus of an atom where electrons reside in. So orbitals, they are what? They are regions around the nucleus of an atom where electrons reside in. Just like shells are regions around the nucleus of an atom where electrons also reside in. That's the same way orbitals, they are also what? Regions around the nucleus of an atom where where electrons reside in also. So from here, we'll be talking about number of orbitals in each of what? Of the subshells. Now, please take note that the S subshell is the first subshell, and because it's the first subshell, it has what? It has one orbital. So please take note, the S subshell has what? One orbital. It has one what? One orbital. One orbital. So please take note that the S subshell has one orbital. Now the P subshell has what? 3 orbitals. 3 orbitals. So the P subshell has what? 3 orbitals. Please take note of this. Then the D subshell has 5 orbitals. 5 orbitals. So the D subshell has what? 5 orbitals, while the F subshell has 7 orbitals. 7 orbitals. So please take note that the F subshell has what? 7 orbitals. So the S subshell has 1 orbital, the P subshell has 3 orbitals, the D subshell has what? 5 orbitals, while the F subshell has what? 7 orbitals. So let's take note of all these that I just brought out right now. Now, in filling electrons in orbitals, there's a sequence or a pattern that we normally use. Now, the sequence is this. The thing of this sequence I'm about to bring out right now. The sequence we normally use is this, which is this 1s, 2s, 2p, 3s, 3p, 4s, 3d. I'm going to stop here for the first 20 elements. I'll be stopping here for the first 20 elements. So this is the sequence that we use for filling electrons in orbitals. So in the process of filling electrons in orbitals, we use sequence, and the sequence we use or the pattern we use is this, which is the 1s, 2s, 2p, 3s, 3p, 4s, and 3d for the first 20 elements. I'm working with the first 20 elements. So this is the sequence that we use. When we start taking examples, I will talk more on this sequence. So from here, let's also talk about orbital diagrams. So because in filling electrons in orbital, there's a diagram that we use, which we refer to as what? As the orbital diagram. Because at the top of the orbital diagram, we normally label this sequence at the top of what? Of the orbital diagram. So I'll be sketching the diagram right now. The diagram looks like this. It looks like this. It looks like this. Here we have the first one here, which is what? The 1s. We have what? 1s here. And the next one is what? 2s. We have to put 2s here. And the next one will be 2p. 2p. We have 2p here. After 2p, the next one is 3s. We have 3s here. After 3s, the next one is 3p. 3p. We have 3p here. After 3p, next one is 4s. 4s. Now after 4s, next one is what? 3d. 3 what? 3d. Of 1, 2, 3, 4. So 1, 2, 3, 4, 5. 3d. 3d, yeah. 3d. So these are is looks like. So these are what the orbital diagrams looks like. Now, if you look at it, what this first diagram here is what is 1s. Now, if you look at it very well, earlier on I said that the S subshell has what 1 orbital. Now, if you look at it very well, now this first one is happen to be what the 1s. Since the S orbital, it was always have what 1 diagram. Now, the next one after the 1s is what 2s. Now, if you look at it very well, the S orbital has what 1 diagram. So that's the reason why we also have what 1 diagram here. After the 2s, the next one is what 2p. Now the p subshell has what 3 orbital. Now if you look at it very well, that's why we have what 3 balls here. 1, 2, 3, 3 orbital. Now after the 2p, the next one is what 3s. As far as under the word the S subshell, it must have what 1 orbit, 1 diagram here. So that's the reason why it is 1 here. Now after the 3s, we now have what 3p. So 3p, if you look at it very well, p has what 3 orbitals. So that's why this has what 3 balls here. Now after 3p, we now have what 4s. 4s under the S subshell. That's the reason why it's having 1 bus here. Then after the 4s, now what 3d. Please take note that 4s come before what 3d. Now after the 4s, now what 3d. Now what about the d? D have what 5 orbital. Are you seeing now? D have what 5 orbital. And if you look at this very well, you see that it has what 5 orbital 1, 2, 3, 4, 5. Because D will have what 5 orbitals. So that's the reason why it is having what 5 orbitals. Now this diagram is what we normally use to feed electrons in orbitals. So these buses are where we normally feed electrons. Then the number of the electrons in each of the buses, we're not writing it as a power on top of the S, on top of the subshell, that is the S subshell, or the P subshell, or the D subshell, or the S subshell. But I'll be stopping here for the first 20 elements because I'm working with what the first 20 elements. So with this sequence, or with this pattern, and then with this orbital diagram, we can write down electrons in what in orbitals. So this is the process in which we write what electrons in what in orbitals. Well, when we start dealing on examples, we'll work at this very well. So from here, before we move straight to examples, now let's talk about because there's some principle and a rule that guides filling of electrons in orbitals. So let's talk about some of those principle and rule. The principle and rule include we have the Bow principle, we have the Pauli exclusion principle, and then we have Horn rule. So these three guide filling of electrons in orbitals. So let's talk on them. So the three of them guide the filling of electrons in orbitals. Bow principle states that when filling of electrons in an orbital, you must start with the orbital with its lowest energy level. And now, if you look at this orbital, like I said earlier on, I'm dealing with the first 20 elements. That's the reason why I'm stopped here. It still extends from here. So I'm dealing with the first 20 elements. And Bow principle states that when filling electrons in orbitals, you must start with the orbital with the lowest energy level. And at the orbital here with the lowest energy level here is the 1s. So if you want to start filling electrons in an orbital, we start with the orbital with the lowest energy level, which is with the 1s, the 1s. Now just like when I was teaching one of my previous videos, when I was teaching on shared and energy level. Now if you want to start filling electrons in shares, you start from where? From the K share, which is the one closer to the nucleus of the atom. That's the same way. If you want to start filling electrons in orbitals or in orbital diagram, you start with the one with the lowest energy level. I propose that Bow principle, which is the 1s. So if you want to start filling electrons, you start from where? From the 1s. So that's what Bow principle is trying to talk about. So moving on from here, we'll be moving straight to the Pauli exclusion principle. Now, Pauli exclusion principle states that when filling electrons in orbital, it states that each of the orbitals must carry maximum number of 2 electrons, and the electron must be in opposite orbit. So Pauli's exclusion principle states that when filling electrons in orbiter, each of the orbiter must carry what? A maximum number of 2 electrons, and the electron must be what? In opposite orbit. Now, this is what the law is the principle is trying to say. Now, normally we must start from what? From the first orbiter with the lowest energy level as proposed by the above principle. Now, if we now start filling of electrons, each of the orbital must carry maximum number of what? Of 2 electrons, and the electron must be what? In opposite orbit. Now, if filling electrons in orbitals, we normally use arrow to indicate what? Electrons, and the arrow is this arrow. One arrow like this and like this. Now, Pauli exclusion principle is saying that now each of these orbitals must carry maximum number of 2 electrons, and the electron must be in opposite orbit, like this. Opposite orbit. One of the arrow will be facing up, and while one will be what? Will be facing down. It is not like this, 2 of them facing up or 2 of them facing down. It's wrong. It's wrong. So that's the reason why these principles are guiding us in what? Field of electrons in what? In these orbitals. So one of the arrow will be facing up, while one will be what? Will be facing down. That shows that the electron is what? Is paired. So please take note of this. So this is what Pauli's exclusion principle is saying. It says that when field of electrons in orbiter, each of the orbital diagram must be filled with maximum number of what? Of 2 electrons, and then the electron must be what? In opposite orbit or opposite spin. So please take note of this. Now let's talk about Horn's rule. Horn's rule states that when filling electrons in orbital or the orbital diagram, you must feed them singly first before pairing will have to take place. Now, what this rule is saying that before pairing, when we say pairing takes place, which means one of the electrons, which is being represented by arrow, one of the arrow will face up before another one will face down. Now 2 electrons must be in what? In one orbital diagram as proposed by the Pauli exclusion principle. But before the pairing will take place, each of what? This orbital diagram must be filled singly first, which means some of them will have what? One electron first before what? Pairing will have to take place. So that's what Horn's rule is trying to talk about. So before pairing, like here, there'll be 1 electron here, there'll be one. Okay, let's use the P. Let's use the 2p. There'll be 1 electron here like this. There'll be another one here like this. You feed them singly first before pairing. Another arrow that's facing down, another arrow that's facing down, another arrow that's facing down will what? Take place. Now, when another arrow that is facing down is now joining the one that is facing up, pairing has now what? Took place. So that's what the Horn's rule is what is trying to talk about. So having explained all this now let's now take what? Let's now take examples. Let's now take what? Take examples. Now we'll be working with what? With the first 5 elements in the periodic table, which are going to be hydrogen, helium, lithium, beryllium, and what? And boron. So we'll be working with what? With the first 5 elements in the periodic table to what? To explain all these that I've just brought out right now. So let's start with what? With hydrogen. So hydrogen. The first thing, hydrogen has what? Let's start with hydrogen. And hydrogen has what? Atomic number 1, which means it has what? 1 electron. So you will start with what? With the first, you must always start with the first orbital. You must always start with the first orbital, which has what? 1s, as proposed by what? By above principle. So you must always start with what? With the first orbital. So it will be what? You start like this. You start what? Like this. Start like this. Now hydrogen has what? 1 electron, because it is the first element in the periodic table. So it has what? 1 electron. So you start with the arrow. Arrow are usually be used to represent electron in orbital. You start with arrow. Then now up here, 1s, you now write 1s, then 1s1. This 1 here is written as power. Now, this one is written as power at the top of this s is talking about what? Electrons. It's talking about the electron of what? Of hydrogen. So please take note of this, that this s is written as the power on top of what? This s is representing what? The 1 electron that will rotate here in this orbital what? In this orbital diagram. So this is what? 1s1. So the electronic configuration of hydrogen using orbital is what? 1s1. So please take note of that. So this is the way you represent it for hydrogen. Now let's move to the second element in the periodic table, which happens to be what? Helium. So let's talk about helium. Atomic number of helium is what? Is 2. So the atomic number of helium is what? Is 2, which means helium has what? 2 electrons. So you start with the diagram like this, you sketch it like this, Now, atomic number for helium is what? Is 2, which means helium has what? 2 electrons. Because helium has 2 electrons, they are going to do it like this. They're going to write it like this. Electrons are usually represented with arrow under what? Orbitals. One will be facing up, while one will be what? Facing down. As proposed by what? By the Pauli's exclusion principle. So one electron will be facing up, while one will be facing what? Facing down. The electron must be what? Opposite spinning. So think of that. There will not be what? 1s what? 1s what? 2. Now, the 2 that is after the power at the top of the earth is telling us the number of electrons of the element you are working with. Are you seeing it now? Now, if the s orbital is not, or if the orbital we are working with is not filled with the maximum number of electrons that can carry, you have no right to move to the next orbital. Now, s orbital can carry a maximum number of what? Of 2 electrons. We did it before, we saw it before. If you did not go through it, just shift the video backward and watch it. We did it before. The s orbital can carry what? Maximum number of what? The s sub Shami can carry maximum number of what? Of 2 electrons. So it must be filled with the maximum number of electrons that it can carry before you move to the what? The next subshell. So helium, we're still working with this 1s. So this 2, the power is telling us the number of electrons that the element you're working with have. So this is for helium. So let's talk about what? For lithium. For lithium is the third element in the periodic table and has atomic number 3, which means it has what? 3 electrons. So we are going to start with this. Same process. The one with 1s here. Lithium has what? 3 electrons. And you must always start with what? With the 1s, as proposed by the above principle. You must always start with what? With the 1s. The one that has what? The lowest energy level, which is the what? 1s. And now s subshell can carry a maximum number of what? 2 electrons. And lithium has what? 3 electrons. But the process will be like this. We'll write it like this. The electrons must always, any pairing you do must always be in what? In opposite form. One arrow facing up and one arrow facing down, as proposed by Pauli exclusion principle. Don't forget about that. So there will be 2 here. This 2 that's at the power, that's after the power in this S, is telling us that the maximum number of electrons that this orbital can carry. Now lithium has 3 electrons. Lithium has what? 3 electrons. But this 1s can carry what? Maximum electron of what? 2. Which means that it's remaining what? 1 electron for lithium. So at this point now, what will happen is that we will not introduce the next orbital diagram, which happens to be what? The 2s. Because after 1s is what? Is 2s. So the next one is what? 2s. Now, how many electrons that remaining for lithium to be complete? Is 1 electron. So we now put it what? 1 here. Are you seeing it now? So we now put what? 1 here. So this how what to represent it for what? For lithium. You see what? Orbital. This how what to represent for lithium. And let's move to the next one, which will happen to be what? Beryllium. Let me put the what? Beryllium. Be atomic number 4. Now you start with the same process with the 1s first. 1s. Beryllium has atomic number what? 4, which means it has what? 4 electrons. Now what will happen here is that now the s 1s is what? 1s can carry maximum number of what? Of 2 electrons. So s can carry what? Maximum number of what? Of 2 electrons. So please take note the electron must be in what? In opposite orbit. Now when I introduce the next orbital diagram, because beryllium has what? 4 electrons, and s can only carry maximum of 2 electrons, which means it's still remaining on that 2 electrons. So now introduce what? The next orbital diagram. So we'll now put the 2 electrons here. Don't forget the electron must be in opposite orbits. Don't forget they must be in opposite orbits, as proposed by the Pauli exclusion principle. Don't forget about that. So this has to represent for lithium, for beryllium, for the which is the 4th electron in the periodic table. Now let's move to the last one, which happens to be boron. Boron has atomic number 5. So we'll be starting with what? With the first orbital diagram, which happens to be the 1s. boron has atomic number 5, and the 1s can carry maximum number of what? Of 2 electrons. They must be opposite form. One facing down, one facing up. Then introduce the next one. Don't forget it has 5 electrons. The next one, which is the 2s. Don't forget, you must put, okay, I forget to put it here. 1s2. One what? 1s2. For this first one, then now what? 2s2. Don't forget that the power we are seeing here is the number of electrons that each of these balls or this orbital can carry. Don't forget. Now, same thing happens here. We have 1s2. These two that act as the power here is telling us that this balls or this orbital, which this 1s, can carry maximum number of what? Of 2 electrons. Then this 2s can carry maximum number of what? 2 electrons also. The electrons are in opposite spin, one facing up and one facing down, to show that it is a pair. Now, boron has what? 5 electrons. So 2 is here, remaining 4. Then we now have to introduce what? The next one, which will be the 2p. 2p. Introduce what? The next one have to be what? The 2p. 2p. Now, so we now put what? The last electron here. We'll put the last electron here. So now 2p1. Now this one is telling us the number of electrons that is in this p area. So 2p what? 1. Now p. Now for the p, let me also say something to us for the p side. Now this p, because it has three orbital diagram. Because the p has 3 orbital diagram, so we have what? 2py, 2ps. Now 2ps, 2py, and 2pz. So please take note of this also. Now 2ps, 2py, and what? 2pz. The reason why is this because p now has what? 3 diagram. One here, one. These 3 orbital diagrams. So now be 2ps, 2py, and 2pz. You must always start with the first one first. In field of electron in the p side, in the 2p's, you must start with what? With the first diagram in the p's area. So that's how this is how what you see what? Electrons. Now, under orbitals. So with this, we have come to the end of this lesson. If you find this class very interesting, I want you to subscribe to my YouTube channel at Divine Online Chemistry Tutorial. Don't forget what to like my video, to share, and also what to comment. Bye, and see you in my next video.